Ingenuity remains attached to the belly of NASA's Perseverance rover, which touched down on Mars February 18. On March the 21st, the rover deployed the guitar case-shaped graphite composite debris shield that protected Ingenuity during landing. The rover currently is in transit to the airfield where Ingenuity will attempt to fly. Once deployed, Ingenuity will have 30 Martian days, or sols, 31 Earth days, to conduct its test flight campaign. Flying in a controlled manner on Mars is far more difficult than flying on Earth. The red planet has significant gravity, about one-third that of Earth's, but its atmosphere is just 1% as dense as Earth's at the surface. During Martian daytime, the planet's surface receives only about half the amount of solar energy that reaches Earth during its daytime, and nighttime temperatures can drop as low as -130 degrees Fahrenheit, -90 degrees. To fit within the available accommodations provided by the Perseverance rover, the Ingenuity helicopter must be small. To fly in the Mars environment, it must be lightweight. To survive the frigid Martian nights, it must have enough energy to power internal heaters. The system, from the performance of its rotors in rarefied air to its solar panels, electrical heaters and other components, has been tested and retested in the vacuum chambers and test labs of NASA's Jet Propulsion Laboratory in Southern California. Before Ingenuity takes its first flight on Mars, it must be squarely in the middle of its airfield, a 33 by 33 foot 10 by 10 meter patch of Martian real estate, chosen for its flatness and lack of obstructions. Once the helicopter and rover teams confirm that Perseverance is situated exactly where they want it to be inside the airfield, the elaborate process to deploy the helicopter on the surface of Mars begins. The helicopter deployment process will take about 6 sols, 6 days, 4 hours on Earth. On the first sol, the team on Earth will activate a bolt-breaking device, releasing a locking mechanism that helped hold the helicopter firmly against the rover's belly during launch and Mars landing. The following sol, they will fire a cable-cutting pyrotechnic device, enabling the mechanized arm that holds Ingenuity to begin rotating the helicopter out of its horizontal position. This is also when the rotorcraft will extend 2 of its 4 landing legs. On the 6th and final scheduled sol of this deployment phase, the team will need to confirm 3 things. That Ingenuity's 4 legs are firmly on the surface of Jezero crater, that the rover did indeed drive about 16 feet, about 5 meters away, and that both helicopter and rover are communicating via their onboard radios. This milestone also initiates the 30 sol clock, during which time all pre-flight checks and flight tests must take place. As with deployment, the helicopter and rover teams will approach the upcoming flight test methodically. If the team misses, or has questions about an important pre-flight milestone, they may take 1 or more sols to better understand the issue. If the helicopter survives the first night of the sequence period on the surface of Mars, however, the team will spend the next several sols doing everything possible to ensure a successful flight, including wiggling the rotor blades and verifying the performance of the inertial measurement unit, as well as testing the entire rotor system during a spin up to 2,537 RPM, while Ingenuity's landing gear remain firmly on the surface. Let's hope for the best. Don't forget to like the video and subscribe for the latest updates.